Nakano, Nakano. Oh, I must say.
Yeah.
Question. Do you know if all the group members have to present for the project charter next class?
Um, Sir never specify.
All right, cool.
You,
Hey guys, how are you doing today?
Fine, sir.
Good, 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 good. Um, so what I'm gonna ask you to do for me is oh Lord, did I send it off? Carno, did I send anything to you, Papa? Can't remember.
Yes, sir.
Okay, thank you. All right. So what I'm gonna ask you to do for me in the meantime, I deliberately not send off the second half of the calculations. What I want you to do for me is to make an attempt to solve the first order partial derivatives using the simultaneous equations and let me know what it is that you have. So I'm going to give you a few minutes to do it. And then based on where I'm at just now, I should be able to project the other half of the calculation. So please, while we wait on
Sir,
the others to join, please
sir.
to give it an attempt. Go, Carno.
What you sent was what we were doing in class on Monday, you know.
I know, but the question wasn't finished, was it?
Um,
No.
mm, which is the final
So
part.
we did the first order partial derivatives, the second order partial derivatives, and the cross order partial derivatives, right?
Yeah.
Right. And we came up with the so you're now need to set the first and second order partial derivatives equals to zero and solve. So that's what I want you to do for me now. All right. Are we guys okay so far? I don't want anybody to be sitting and not having anything to do. Are we okay understanding my instructions?
So I can't speak for myself. I'm here trying to figure it out what's reaching nowhere.
All right. So I gave you a multivariable function the last class, and then I asked you to go ahead and do the first order partial, the second order partial, and the second order cross partial derivatives. All right. Don't walk, and we did the second cross order partial derivatives. Then we got the first two, the first order partials, and I'm asking you to set the first order partials to be equal to 0 and to solve. You remember I said to you that when you're solving simultaneously, you may have to be able, yeah, you may solve simultaneously, but you may also be required to work the equations one independent of the other and then substitute the answer in the second equation. Remember that what we did before? So the question that we did in class was we only formed the first order, second order partial and cross partials. You don't need to solve the equation simultaneously. So we just went halfway in the question. So what I'm asking you technically to do
No,
is to
sir.
complete the question
We
from,
move way past that, sir.
no man, did we do the simultaneous?
Yes, sir. We did it, sir.
Okay,
Well, I think so.
so what, okay, go ahead and classify for me then now. Classify. Is it relative maximum, relative minimum? Go ahead and classify for me.
Okay.
I know there's something else that wasn't done. So classify
Sir,
the,
sir.
how many critical points you got?
4.
4.
Four. Ah, we got 4 critical points. Classify each of those points for me, please.
Oh, you just that's all you want for this, sir?
Yeah, to finish the
Oh, okay,
question.
we can do that. All right,
Yeah,
good.
so finish the question for me. So are we on the wavelength now? The same wavelength?
Yes, sir.
Okay. I'll give you a few minutes to do that for me, please.
Yes, sir.
All right. Have you classified all the points now? Yes, no, maybe so.
A few, sir. A few. Just
A
two
few.
more, sir.
You have two more. All right. So remember, it's going to be f of x times f of y minus f of xy all squared. So in this here case, based on what I remember from the question, you will have to make a substitution into f of xx and f of yy and f of xy because it's not whole numbers. You got an expression, true or false?
True, sir.
Yeah, man. So it's going to be a little longer. So that's the point I'm making. The point I'm making is the other two questions we did in class were shorter questions and they won't be for 30 marks. If you get a question like that, it's going to be a 20 marker or a 15 marker. But if you get a question of this nature where it's a lot more calculation, it will constitute to be a 30 marker. All right. So I give you another 5 minutes to finish off this, and then I'm going to drop one more. All right. I'm going to work in. All right. How we stay? Are we finished? You must be finished by now.
Yes, sir.
Okay. Because I recognize if I don't call to when another one call to me, you know, to say, sir, finish. All right. Let us see where we are. By the way, it's just Domoy I heard. What about the rest of you?
Yes, sir. Finish. Send me to the hands out. I'm not sure if you tried. I'll let me
All
know.
right, no problem. No problem. We'll definitely look at that for you. Or we can go through and go through it together. Uh,
So if you have a fish out of water, no, no, why? But, you know.
you don't know what to do? All right, no problem. All right, so guys, so yes, if you follow what it is that I mean, keep up with what is happening in your classes. I am suspecting that you all will be very successful in the final exams to come. Recognizing that there's only a few students in class tonight, not sure why. I didn't get any message to say, sir, we're going to be absent, but oh God. I am suspecting that you will be able to do well, guys. This team, you know, this team here, honestly. Oh.
Recording in progress.
All right, so
Good evening.
hey Taj, what's up?
Here, just getting in.
All right, never mind. What we're going to go through now is the solution to the the stationary point question that we did last time around. And guys, my computer restarted, so my open document went. See, there's something I'm going to do. My open document went, so I am trying to get it back. So which all right, so let us start with the x equals 0, y equal 1. Was that one of the stationary points? X equals 0, y equal 1. Is that a
No,
yes
sir.
or
No,
no?
no
So me
answer.
have you so where the total critical points are -1 and 1, then you have 1 and 1, then 0 and 0, then 0 and 2.
Negative 1 and 1, 1 and 1, 0 and
0, 0, and
And
then
okay,
0
0
and
and
2.
2.
and 0, 2. All right. So tell me now the negative. All right, give me the for the 0, 0. What is it?
Sir, I think it's the local maximum.
Okay. Everybody agree with that local maximum there? Somebody talk to me, please. All right, Demoy, what you got for
Yes,
02?
02, sir, that would be the local minimum.
Okay, and what you got for 11?
Saddle point,
And what you got for negative 11?
saddle point.
Okay, good job. Very good, Papa. All right, for those of you who didn't answer because clearly did not work, allow me to project. Oh gosh. Mm. Just take a look at that for me, please, quick and fast, because you have another question on its way. Quick and fast for me, please. How we feel, how we say. Like I don't like the idea that you just sit down there and I don't want to not engage in
I
it.
don't understand one thing.
Yeah, but I mean, if I never say anything a while ago, you say something.
No, sir, come in and look through it and try understand it. Understand you get -6. For the top understanding that out and the rest.
All right. We'll have to talk to the teacher, not sure. Let me. So tell me if you agree with this formulation. Are you in agreement with that formulation? F of x times f of y minus f of x by all squared.
Repeat, sir. Sir?
I'm saying to you, do you agree with the f of x? D is going to be f of x times f of y minus f of xy all squared. Do you agree with that?
Yes, sir. Yes, sir.
Okay. So what is going to happen now, Carno, is I'm looking at my stationary point. Let me bigify this one for my explanation. What it is that you're doing here is you're using the coordinates 0, 0. You're using the coordinates 0, 0. So remember, as I recall it right here, your f of x is 6y minus 6. Your f of y is also 6y minus 6. Your f of xy is 6x, and yx is also 6x. So in order to substitute it, so this is now the last part of the question, to classify the nature of the critical points. What you're doing is to say f of x minus f of y times f of xy all squares. Your stationary point is 0, 0. So what is going to happen is your f of xx at the critical point 0, 0, at the, when I gave you this, formulation, I want all of you to look here. When I gave you this formulation, your D of AB is going to be your f of xx AB. Your AB is your critical point. Your f of xx AB means that you're going to substitute your AB at that critical point. So sometimes when you do the question, you get whole numbers. There is nothing for you to substitute in. But there are times we have something to substitute. So it's going to be f of xx AB times f of yy AB minus f of xy AB all squares. What is AB, sir? The critical point. Let us go. It says, suppose that AB is a critical point of f of xy. So it means that f of xy is your function and AB is a critical point. As you're seeing in this case, you can have several critical points. And that the second order partial derivatives are continuous in some region that contains AB. Why the second order partial derivative? See to yourself, f of xx, f of yy, f of xy. Your second order partial derivative for x, your second order partial derivative for y, and your second order cross partial derivatives. So see to yourself, and that the second order partial derivatives, which includes this, this, and this, are continuous in some region that also contain that critical point. So what's the point I'm making? Point I'm making is, this is a critical point of the function f of xy. And for some second order cross partial derivatives or cross order derivatives, it contains this critical point. How it contains it, sir? Theta. You have one y right here, so. You have one y right here, so. And you have x and x. So what you're going to do is to substitute the values in the function. So f of xx, you look for f of xx, 6y minus 6. X is equal to 0, y is equal to 0. So it's going to be 6 times 0 is 0, minus 6 is going to just be negative 6. And f of yy is the same thing. So that we're going to be minus 6. Minus f of xy, you then put 0, 0. Xy and yx will always be the same. And 6 times 0 is 0. So that is going to be 0 squared, which is 0. But negative 6 times 6 is positive 36. And 36 is greater than 0. So the value of D is positive. Now, since D is positive, we need to look at the value of f of xx. If f of xx is positive, we have a relative minimum. But if f of xx is negative, we have a maximum. See, f of xx here, f of xx works out to be negative 6. So it is a maximum. So, I mean, it's negative. So therefore, we have a relative maximum here. Are you understanding that?
Yes, sir. That's the light.
Very good. Pay me later. Similarly, what it is that I'm doing, again, I'm recalling my first. So do you understand now how important it is for you to do your derivatives, your partial derivatives correctly? Because it's not only the first order partial you're going to be using, you're using everything. You're using everything. So you have to make sure that the partials are correct. You have to make sure that the partials are correct. All right, let's just work through this one. Very good, Demoy, for getting them correct. And for anybody else who has gotten them correct, no problem if you just seen it. I'm happy. All right, let us go. So again, I'm recalling what my f of xx f of y, and f of x, y, x are equal to, I'm now looking at a new critical point. My new critical point is 0, 2. I'm going to substitute my 0, 2. My x is 0. My y is 2. 6 times 2 is 12. 12 minus 6 is this 6 here. So, and because both functions are the same, it means f of y is also going to be 6. But x is still 0. X is still 0. So 6 times 0 is going to be 0. So it's still going to be 0 squared, which is 0. And 6 times 6 is 36. So the value of d here again is positive. So because it is positive, we have to now go ahead and check f of xx. But f of xx is also positive. Once we have a double positive, we have a relative minimum. If d is positive, but f of xx is negative, we're going to have a relative maximum. All right, let's go. Are you okay with that one?
Yes, sir.
Yes, sir.
So what to the rest of you? Answer me, no, man, please. Let me know so when I learn.
Yes, sir. Yes, sir.
Yeah, man. Answer me, man. It's not nice when you're having a conversation and you're talking to yourself. All right. Now I'm going to be looking at 1, 1. Again, for ease of convenience, what I did was to recall what my function, my partials look like. 1, 1. My f of xx, x is 1, y is 1. I don't business about x because there's no x here. Over here, so I don't business about y because there's no y. 6 times 1 is 6. 6 minus 6 is 0. Whoa, so we have 0 and 0. But in this case here, x is 1, because 6 times 1 is 6. So we have 6 squares. So 0 times 0 is 0 minus, you notice the negative sign is outside. And then I'm going to square positive 6. I'm going to get 36. So all of this now becomes a negative 36. The mere fact that it is negative is saddle point. I don't have to check anything about f of xx. So once d works out to be negative, boom, saddle point. Similarly, finally, I should say, negative 1 and 1. Negative 1 and 1. Y is 1. 6 times 1 is, I'm going to get 0 again here. And 6 times negative 1 is a negative 6. But when I square a negative 6, I'm going to get a positive 36. So it's going to be minus 36 again. D is negative. I have a saddle point again.
Yes, sir. Got it. Got it.
All right, good job. I'm
So,
happy.
so I mean, you get it wrong. So, I don't know. I guess from the equation that me that try work out the points and me get it wrong.
But so tell me though, are you understanding that better now?
To some extent, sir.
All right, to some extent. All right, no problem, Pops.
Yes, sir. A little bit. Still not fully there, but a little bit.
But
All right.
sir, in regards to the working on for the point, we just scroll up and see it and just see where I went from. See.
What you talking about, Papa? Talk to me now.
Yes, sir. We will get 0, 2 and 1, 1. Those points.
What about it?
I didn't get the same point. I don't know if I did something wrong. Seems as if I did something wrong in calculating.
Tariq, you're somewhat muffled. I'm not hearing it so clearly.
Okay, here you know.
Yeah, man.
I'm saying the points that you got the 1, 1 and the 0, 2. I did something wrong with the calculation, so I just wanted to see how you calculated that.
You want me to explain it or you just want to look at it?
You can explain it, please, sir.
So what I'm saying, so you agree with the stationary point 0.02, right?
No, sir. That's where.
You know, Tariq, you should have told me that he didn't agree with that from last class. So the 0.2 here, when x was 0, we substitute it into the original, into the second equation of f of xy, and we got y equals 0 and then y equals 2. And remember, I was saying to Andrew, not Andrew, yeah, Andrew, that he's not supposed to go ahead and cancel. However, what I want him to do is to factorize. You remember that conversation?
Oh, yeah, yes, sir.
Mm-hmm. And that's how we got the x equals 0, y equals 0, and x equals 0, y equals 2. Tariq, did you look over the handout that was circulated on Monday? Yes or no?
No.
I kind of figured. that. That's why you're asking me the question you're asking me. Because the question you're asking me is not about today's class. The question you're asking me is about from Monday's class.
Oh, okay, sir. Yeah.
Yeah, man. So you just
Yeah.
need to go through. So what we're
Yeah,
doing
yeah.
today is having us. We're working on the assumption that our critical points are negative 1, 1, 1, 1, 0, 0, and 0, 2. What we're doing for today is just going ahead and substituting into our general formula to be able to classify each of those critical points. So remember, it's going to be f of x, x, xy times f of y, y, xy minus f of xy all squared.
Yes, sir.
Good.
I get that part, sir. It's just that the
Okay.
point.
It's just that it's 0, 2.
Yes,
Revise
sir.
what it is that we did the week before, and it should be fine.
Yes, sir.
All
I'm
right.
looking at it now.
All right. Good job.
Thanks.
No, no problem. Um, what time is it? 6:13. Should I give you an easy one or should I give you a hard one? All right. Let me give you
Easy.
no.
Yes.
All right. Okay. All right. Fine. Let me give you an easy one and then you can do a hard one. All right. Let me give you an easy one and then you do a hard one. Because guys, we're getting this, this carry enough marks. We're getting this. It carries a whole lot of marks.
Sir, so are we usually required to plot the graph after for the rest of the marks or just do the calculations?
Not for the multivariable function. The multivariable function plot is going to be a little bit tricky than the single variable function. I will show you how we'll give the practical questions for the multivariable. I don't reach the practical questions yet. And I'll explain to you when I get there what I mean by practical questions. I'm going to give you an easy one. So to just, for Tariq's sake. All right, do me a favor. Quick and fast. I'm giving you f of xy is equal to 2x squared plus y squared minus 2xy plus 5x minus 3y plus 1. I want you to go ahead and find 6 partial derivatives. Set your first order partials to be equal to 0. Solve simultaneously or otherwise. Do what you need to do to find a critical point. And I want you to classify. It's now 6:15. I'm giving you 10 minutes. Start for me, please.
Yes,
Finish?
yes, sir.
Good job. Anybody finish? No.
Almost.
All right. Let me see. Let me hear what the I gather that some people are stuck at a point. What do we have for f subscript x?
4x
4x
minus 2y
minus
5.
2y plus 5.
I'm hearing 5y, which is it?
7 but
4x,
that's a 5y.
4x minus 2y plus 5.
Somebody said 5y.
Sir,
So the
no,
person who
sir.
said somebody who said 5y, are you okay with 4x minus 2y plus 5?
Sure, yes, sir.
What is f of xx?
4.
F subscript y.
2y minus 2x minus 3.
What is yy?
2.
Xy.
Negative 2.
2.
2, sir.
2.
Negative 2.
Negative 2.
Negative 2.
Negative 2, right.
Negative 2.
Negative 2.
Are you in agreement with the negative 2? All of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. What am I to do next?
Sir, set them to 0. That's
Set
subscript
who?
F subscript X and F subscript Y.
Okay. So I'm going to set F subscript X and F subscript y to be equal to 0. So this is it. So f subscript x, when I set equals to 0, this is it. So f subscript x was 4x minus 2y plus 5. I set it equals to 0. F subscript y is 2x minus 2y minus 3, and I set it equals to 0. This implies that 4x minus 2y is going to be equal to a negative 5. See here, my equation 1. And then 2y minus 2x is going to be equal to a positive 3. See it right here, so? But look at what Sir did. Sir flip this negative 2x up front so that all the x's could line up under each other and all the y's lined up under each other. Tell me that you see this.
Yes, sir.
Yes, sir.
Go
Sir.
ahead and
Change the
solve.
molecule.
Say it again.
Yes, sir. No problem.
Okay. Okay. Can you go ahead now, take it from there for me, please? Solve it simultaneously. Get me the critical value or critical values. I'm not telling if it's 1 or 2. Matter of fact, are you expecting a critical value or are you expecting critical values?
Sir?
Critical values.
Critical values or value?
Values. Values, sir.
Values, okay. Anybody think it's just a value?
Sir, values, sir, because we are expected to substitute a y value and x value into the formula.
But it's a linear equation, correct, sir?
Yes, it is.
So it's value singular.
Very good. Thank you, Rayton. Remember, no Alvin. There are two linear equations that we're talking about. Linear means that the highest power in both x and y are raised to 1. So because both x and y in both equations are raised to the first power, we will get a critical value. If one of the equations had a square term, then we would have critical values. So you have to be mindful. So when I look at these equations, I know I'm going to have only one value, critical value or critical point or whatever the situation is. All right? All right. Continue
Yes,
for me,
sir.
please. Quick and fast.
Sir,
Yeah, man.
until if we wake up, ready now.
Say it again.
Are you ready? Tell the man,
sorry.
tell me if it right. But I try
I'm not
something.
full. Okay, you're saying that you are ready. Okay, what about the rest of you though? Drop it in the chat for me, please, Kenneth.
All right, sir.
Ready to, sir.
Drop it in the chat for me, please, while the others work. Some students are struggling with the simultaneous, so I don't want to project the simultaneous. I want to give them an opportunity to do it. So if you're finished with the simultaneous, just drop it in the chat and I will communicate with you there, please. Thanks.
Sir, check the chat.
You not see your response? I responded to you a long time.
Oh, my bad, sir.
Okay, cool. Tariq, check the chat for me, please, Tariq.
Yes, sir, I'm working over,
Okay,
sir.
cool. All right, cool. Thanks. All right, so far, most of you are there. Let me run through for some of you who may still have a challenge. I have my pair of simultaneous equations here. I have my pair of simultaneous equations. And I'm solving simultaneously. I'm solving simultaneously. So look at what is happening here now. If I were to add the y's, minus 2y plus 2y, what does that give me?
Zero, sir.
Zero.
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 So it means then that I would have eliminated my y. So therefore, I'm going to add my x's. So minus 4x, sorry, 4x minus 2x is going to be 2x. See it right here. So this is a 2x. And minus 5 plus 3 is a negative 2. So when I add equation 1 to 2, but remember, our aim is to get the coefficient of either x or y to be the same. When I look at the equations above, I recognize I have minus 2y and I have positive 2y. So what happens is the coefficients of the y's are the same. But what is also very important is that the signs are different. So when the signs are different, I'll go ahead and add. And in adding, negative 2y plus 2y is going to be equal to 0. And 4x minus 2x is going to give me 2x, which is this. And negative 5 plus 3 is going to be negative 2. When I divide both sides by 2, I'm going to get negative 1. I'm going to put x equal negative 1 into any of the equations. I chose equation 1. And what that gives me is going to be 4 times negative 1 minus 2y equals negative 5. So that will be minus 4. I'm adding 5 to this side here. And I'm subtracting 1. I'm adding 2y to both sides. So the 2y becomes a positive 2y on this side. Minus 4 plus 5 is going to give me a positive 1 equals 2y. When I divide both sides by 2, I'm going to get y equals a half. So my critical point is negative 1 comma half. I have this. I'm here. F of x times f of y minus f of xy all squares. F of x was 4, f of y is 2, f of xy is negative 2. So it's going to be 4 times 2 minus negative 2 squares. Negative 2 squares is 4. 4 times 2 is 8. 8 minus 4 is going to be equal to 4. And one square is greater than 0, it means that it's positive. So I'm going to look at the value of f of x, which is also positive. So I'm going to get a relative minimum. And that's it for that one.
Sir, could you scroll back to the simultaneous equation? The second one specifically.
That one there?
Oh, yes, sir. Question, sir. For the first one, you said that the signs being different means you could add, right? If the signs were the same.
You subtract.
Oh, okay.
If the signs are the same, you have to subtract in order to eliminate. The signs are different, you add to, in order to eliminate.
All right, sir. Thanks.
So I'm guessing because the goal there would be to get rid of the y.
Good job.
So
Can I scroll down a little bit, please?
Okay, remember to talk about the next semester.
Tell me which, have you had a conversation among yourselves?
No, sir.
Can you have that conversation in your WhatsApp group for me, please? This is now the 12th of March. And on Monday, you guys are having an award ceremony. For those of you who can come out and do support. I know some of you will be awarded. Congratulations. Let me know which day. I don't want, if I put a date, I'll be here. Oh, sir, we'll have this and we'll have that. And I know you have your other mid-semesters that are coming up. It wasn't timetabled, so I know it would be difficult. Had it been timetabled, then I could say, okay, this day is our day. So have a conversation, please, in the WhatsApp group, and I'm sure when a consensus is reached, Lakana will communicate the date with me. Please and thanks. That's okay.
Okay, sir.
All
Scroll
right.
up
So let
just
me
a
tell you.
little.
Go ahead. Sorry. Question?
Yeah, scroll up just a little, please. Yeah, right there. Right, thanks, sir.
No problem. All right. Let me give you my assessment for today's class. I don't know how much revision was done in preparation for today. It showed up in the quality of work you produced tonight. Number two, a few of you are still having a difficulty with simultaneous equations. The partial derivatives, you're good with that. Congratulations. But a few of you are having a problem moving after you've done the partials to complete the simultaneous equations. The third part of the question in terms of doing the classification, I believe is okay. It's the middle part that is giving the problem. Hear me out. Go study it. Study the middle part. Because what I'm going to do is I want to also screenshot this one for me. Your homework. That's your homework. Topic is not difficult. But if you don't know how to do simultaneous equations, you're going to be in problems. And it shouldn't be difficult, you know why? Because we did simultaneous equations for piecewise functions last semester. And you all here survived. You survived. So do that for me. I'm going to link up next class. Are there any questions? We're wrapping up. Are there any questions? Your opportunity not to speak to me.
No questions here, sir.
Okay, big up on yourself then. Have a good one.
Thanks, sir.